All right, welcome to the deep dive. Today, we're plunging right into a stack of sources that puts us in the middle of a really high-stakes engineering controversy. We are talking about a critical piece of public infrastructure, a massive concrete bridge project.
And not just any project. This was financed by a $260 million U.S. loan.
A loan that, yes, you are helping to pay back.
And that financial context is just so vital here because what we have is a head-on collision of reports. On one side, you have the official government assessment trying to reassure everyone.
And on the other?
On the other, you have these findings from independent counterinspections, including a big one released by VPAC, the Public Accountability Commission.
So our mission today is pretty simple, really. It's to synthesize these conflicting reports and help you understand the actual risk level. I mean, when drivers are on this bridge and they feel these noticeable dips, these shifts, and see visible damage on the road.
Is it just a minor thing, a cosmetic nuisance that's, confined to the asphalt on top?
Or is it a signal of something much darker? Something like a fundamental structural failure happening right underneath their tires.
And that distinction right there between the surface and the structure, that's where this entire deep dive is centered. You're dealing with a complex system. You've got a load-bearing concrete bridge deck. And then on top of that, an asphalt layer.
Which is there for, driving comfort and wear.
Exactly. And the entire official story, it rests completely on the idea that only that top layer is moving.
Okay, so let's start there then. The official stance. The minister weighed in, and our sources repeatedly noted that he was very careful with his words.
Oh, very careful. Crafted, even crafty.
It felt very deliberate, didn't it? Like a real attempt to manage the narrative from the get-go.
It was surgically precise, I'd say. The minister's main claim, it was designed to just minimize any concern. He stated that what people are seeing is, and I'm quoting here, mostly cosmetic.
Because it's just the asphalt.
Right, just the asphalt. So the logic is, if you have some rubbing of asphalt or a bit of surface movement, it doesn't mean the whole $260 million structure is failing.
It's clever framing. You focus all the attention on that top layer, the sacrificial layer, really.
It is clever, but, and this is a huge but, even in that very carefully built statement, our sources say he made a massive, and I think a very revealing, concession.
He did, yeah. He conceded that beneath this shifting asphalt layer,
there's a solid concrete foundation.
And that just, it immediately raises a critical question for any engineer looking at this.
It's a huge one. I mean, if the base is fundamentally sound, if we really do have a solid concrete foundation, then why on earth did the minister even have to bring up the idea of settlement time?
Exactly. Why talk about settling at all?
Precisely. Let's just accept his premise for a second. The foundation is solid, it's stationary. Okay, so the asphalt on top might crack from weather, or maybe it was a bad paving job. Fine. But the underlying concrete bridge deck, that should be completely rigid.
So the very act of discussing structure-wide movement.
It totally undermines his claim that the issue is just cosmetic. It's like an admission, really. It implies that the underlying bridge structure, the foundation he says is solid, is actually moving in a way that's unexpected or excessive.
Wow. So in his attempt to calm fears by saying, hey, it's only asphalt, he accidentally opened the door to the real structural question. Why is the concrete below moving enough to cause this much failure on the surface?
That's it in a nutshell. You don't discuss the settlement of a major finished concrete bridge unless you think the supports underneath the piers, the abutments, are actually moving.
And that leads us directly into the counter-evidence.
This is where the whole narrative just flips on its head.
The inspectors, including that team VPAC brought in, they immediately pushed back. They suggested the minister was either, quote, wrong or he was misled.
They're arguing it's fundamentally not a cosmetic issue.
They just moved the debate right from, I guess, road maintenance to structural integrity.
Instantly. The core finding cited by VPAC is crystal clear. It says, damage beneath the asphalt points to damage in the structure.
That's a huge shift.
It's massive.
Yeah.
Because you're no longer talking about a weekend resurfacing job. You're suddenly talking about heavy, expensive structural repair.
And this evidence, it forces us to confront what they call the structural leap.
Yeah, and VPAC raises the fundamental question. If the structure is affected, is the bridge affected?
And then even more worrying, does this mean other areas may also be structurally compromised?
They're moving past the rhetoric. They are providing physical documentation of what they saw.
And what did they see?
Well, the inspectors, they give these sensory observations that are just.
Yeah.
They're impossible to ignore if you believe their testimony. They described observing areas where people had apparently, quote, gone beneath the asphalt and are now in the actual structure of that bridge.
Wait, hold on. In the actual structure?
Yes.
That doesn't just mean the asphalt is peeling off. That sounds like the physical concrete deck itself is exposed and failing somehow.
It does. It means the load-bearing parts of the deck have been breached. We're talking about materials designed to withstand millions of pounds of stress, not just a bit of bad weather. The inspector even mentioned seeing evidence of what he called cement domesh.
Cement domesh. That's not a standard engineering term I've ever heard. What do you think he was actually observing? What does that mean?
It's likely a layperson's term, or maybe a regional one, for distress in the concrete. See, when a structure is under unexpected stress, the concrete can show signs of spalling, where little pieces flake off, or delamination, where the surface layer separates.
So it's basically degrading.
It's degrading, yeah.
Yeah.
Due to internal stress, or maybe moisture getting in, or friction, it means actual damage to the structural material itself.
So if they're seeing real concrete distress, not just asphalt moving around, that confirms the structural compromise.
It moves the issue from a low-risk road hazard to a very high-risk structural integrity concern. And the movement they described, the visible movement, it backs this up dramatically. They reported seeing the wave coming up and a big drop.
When you feel a big drop in your car, you're not just hitting a pothole.
No, you could be hitting a fault line in the road deck.
Okay, now, if that damage was just in one spot, a localized paving error, that would be one thing. But what really connects all this source material to a bigger, more systemic failure argument is how widespread the damage is.
This is, for me, probably the most compelling single piece of evidence that disproves that whole cosmetic-only argument. The inspector was meticulous about this. They noted the problem isn't isolated to one lane or one spot.
What do they find?
They observed the same wave and the same drop on the opposite side of the bridge around the exact same span.
So near the middle of the bridge.
Right? Near the middle. Which strongly suggests a deep structural issue.
The repetition.
Yeah.
That's the key. Why is seeing that identical flaw on both the eastbound and the westbound decks in roughly the same spot so important? Why does that point to structure and not just paving?
Well, think of it like this. Imagine you have a nice wooden floor in your house. If you drop a heavy hammer in one spot, you get a dent. That's a localized cosmetic fix. Easy enough. But if you have the exact same dip and bump in the exact same position in two parallel rooms,
then it's not the floorboards.
It's not the floorboards. It's the supporting joist underneath that's settling or failing.
So the underlying support element, a pier, a piling, maybe a critical expansion joint, is common to both the east and west decks at that one location.
Exactly. If the failure pattern is repeated like that, it suggests the failure is inherent to the element supporting that entire span of the bridge. It contradicts the idea of a simple asphalt shift. Asphalt is laid differently, lane by lane, but the concrete deck and its supports, they behave as one single structure.
And this evidence points squarely back to uneven settlement of the ground or the supports.
It does, which moves us right into the financial and the engineering implications of all this.
We're talking about $260 million invested in this piece of infrastructure, paid for by you, by the public.
And bridges of this scale, I mean, they're meant to last for decades, often 100 years or more, without showing this kind of systemic structural distress so early on.
It's worrying.
That's why these counter reports are raising such fundamental questions about the engineering and the planning foresight. In any project this massive, especially one built on what might be uncertain ground, the concept of differential settlement. That's the primary calculation.
Differential settlement being how much different parts of the foundation will sink over time.
Exactly. And any experienced engineer building a bridge like this would have known what the settlement time is and all these different things. That's a quote from one of our sources.
The expectation is that those calculations are done beforehand, and the bridge is designed to tolerate that expected gradual movement.
Yes. So if the bridge is behaving this way just a few years after it's completed, it implies one of three things. One, the geological surveys were just fundamentally wrong. Two, the engineers miscalculated the settlement. Or, and this is maybe the most concerning, there was a failure in quality control during construction. Poor execution of the foundations or the deck assembly.
The inspector's concern isn't academic, it's very practical. They ask, why is it that we are now finding out these things that they should have already known?
It points to a profound oversight, a failure of governance or engineering, or maybe both.
And that failure of foresight leads directly to why these counter reports are being issued in the first place.
Right. They are not trying to incite panic. This is framed explicitly as a caution measure.
To be proactive instead of reactive.
That's a phrase they used.
Because nobody wants to read headlines about a bridge collapse years from now that could have been prevented today.
Precisely. And so VPAC's formal recommendation is a practical, immediate demand.
What are they asking for?
They're requesting a qualified engineering inspection, a truly independent assessment to advise the minister and the nation on the real scope of the damage.
The urgency seems paramount here.
It is. And the goal is simple, as they state in their recommendation. Address it now and correct it before it becomes a disaster.
They want independent experts to figure out how deep this structural problem really goes.
And what it will cost, in both money and time, to fix it properly, not just a cosmetic patch job.
That request for independent oversight, it feels like an acknowledgement that once concrete starts showing distress like this, it rarely fixes itself.
It almost never does. It usually compounds, especially with heavy traffic and weather.
Okay, let's bring this all full circle for you, the listener. You've heard two completely competing narratives about this very expensive infrastructure project.
On one side, you've got the official, very careful, very crafted view. It minimizes the damage. It assures the public that this is all just cosmetic asphalt movement on top of a solid concrete foundation.
And on the other side,
You have detailed physical evidence from these counter-inspections, observations of damage beneath the asphalt, of exposed concrete.
and crucially, those repeated systemic waves and drops that are visible on both sides of the bridge deck in the same spot.
That evidence transforms the repair job from a simple paving exercise into a fundamental structural remediation. It implies there's systemic instability in certain support areas.
It's a textbook example, really, of the engineering question triumphing over the political answer.
I think so. The physical facts of that repeated movement just seem to contradict the assertion of a fully solid, stationary concrete foundation.
So here is where we leave you to think. Given the specific source material, that this bridge, paid for with a $260 million loan, was explicitly designed around having a solid concrete foundation, what does the evidence of these widespread duplicated waves and drops imply about the quality control and oversight during the initial construction?
If the movement is systemic, if it indicates an underlying settlement issue.
Was the project oversight sufficient to protect that massive public investment right from the very start? That is the question you need to continue exploring.
And remember, understanding the evidence allows you to hold decision makers accountable, not just for the failure, but for the proactivity required to correct it.
We'll see you next time on The Deep Dive.